time ago in the local universe, two galaxies violently crossed paths. For millions of years, these two galaxies have continued to collide. Due to the force gravity, the environments within these two galaxies have been completely altered. But a new hope was born. This collision provided insight as to what is to happen with our own galaxy. With predicted a collision in the near future, this information is crucial. Only time will tell the fate of our galaxy. Professor James Lowenthal of Smith College Astronomy Department shares his insight on merging galaxies with us. May the force be with him. In the past, galaxies were thought to evolve in isolation. However, today it has been proven that galaxies in neighboring space merge with one another. A galactic merger takes place when two or more neighboring galaxies collide and eventually form one galaxy. An example of this can be seen in our local universe. About 60 million light years away from Earth in the constellation Corvus lies the Antennae system, which has made their first pass about 220 million years ago, and will continue to merge over the next 40 million years. This system is easiest and most interesting to study because it is the closest and youngest system in relation to Earth. The antennae consists of two spiraling galaxies violently interacting to eventually morph into one elliptical galaxy. The antennae system took its name from the long antennae-like arms extending far out from the nuclei of the two galaxies, best seen in images taken by Hubble. These tidal tails were formed during the initial encounter of the galaxies some 220 million years ago. What does this particular merger tell us about what is going to come of our own galaxy? The tidal tails, for instance, are produced when the galaxies are torn apart by gravity. The antennae system has astonishing long tidal tails, which are the location of abundant star formation, that will continue during the merger. However, star formation will begin to slow down once the galaxy starts to settle. In the following clip, Professor Lowenthal explains star formation and the process by which two merging galaxies can be classified as a settled galaxy.
Look at the Milky Way today. We see evidence of past mergers. So does that mean that the merger is still going on or not? On the large scale, the Milky Way is pretty relaxed. It's not what we would call a disrupted system. It's got a nice disk, it's got spiral arms, the disk is a little bit floppy, it's got a warp to it, it's not a perfectly rigid plane, but that's pretty normal. That happens easily from a little perturbation, a little wiggle from some passing galaxy. So you'd say, yeah, the Milky Way is pretty relaxed, but we see these continuing signs, these streams of tidal tails of dwarf galaxies getting eaten up by the Milky Way. So it's hard to define when a merger is done.
Based on what we know about the antennae, we can predict what's going to happen with the Milky Way and Andromeda collide. Although studying the collision of the antennae system provides some great information on galactic mergers and helps astronomers create simulations of when our Milky Way galaxy merges with its galactic neighbor, there's still not enough evidence to provide an accurate prediction of a future collision. The key to understanding the collision's paths of these two galaxies essentially lies in determining their orbits. Currently, astronomers do not know the orbits of the Milky Way and Andromeda galaxy. Therefore, without knowing the orbit in conjunction with the gravitational pull and velocity of the two galaxies, it is difficult to determine when a collision will take place.
Andromeda galaxy and Milky Way galaxy, I don't think there is enough information to predict it accurately, no. And that's because it's practically impossible to know what the true orbits of the galaxies are with respect to each other, which we would have to know. We can simulate if we knew the orbits.
In the end, what do merging galaxies leave behind? After two galaxies of similar or equal mass have merged, they will evolve into an elliptical galaxy. On the other hand, because the Milky Way is thought to be the product of several unequal mass mergers, where a larger galaxy and a smaller galaxy have collided and it did not transform into an elliptical galaxy. As Professor Lowenthal previously stated, the Milky Way is a settled galaxy and continues to swallow surrounding dwarf galaxies.
Right now, the Milky Way has a dozen satellite galaxies orbiting around it, and some of them are actually getting torn apart gravitationally by tides, getting ripped apart by the Milky Way's gravity and spiraling in, getting eaten up, gobbled up by the Milky Way itself. But it's not really having a big effect on the shape or appearance of the Milky Way. It's a pretty subtle thing. It's only recent that we've realized that.
Now that we have more knowledge on merging galaxies, it may be easier for scientists, astronomers, and researchers to unlock the mysteries behind a collision between the Andromeda and Milky Way galaxies. May the Force be with you.